For this video, we are going to talk about the Wronskian of functions. Now, this is already a topic on our linear algebra, but we need to revisit this because one of the processes of solving higher order non-homogeneous equations will involve the concept of the Wronskian. Now, the Wronskian of functions is actually just the determinant of a certain matrix derived from the relationship or the number of functions we are going to deal here. So let's come up with our matrix first. We have here two functions, cosine 3x and sine 3x. This determines the number of columns for our matrix. In short, the number of columns from our matrix would be 2. And the first entry for that column, okay, let me write here the matrix, would be the functions themselves. Okay, that is the first entry for each column. Now, since we are talking about determinant and we can get the determinant for a square matrix, we are also expecting here a 2 by 2 matrix. But there is also another concept that we can follow into that, because the number of rows will be determined by the same functions to be followed by the n-1 derivative of the functions. n-1 here, n meaning the number of functions. We have 2 minus 1, so we only have 1. This tells us about the order of the derivative that we were going to end at. In short, we are just simply going to end at the first derivatives of both functions. Basically, from this function, the first derivative will be placed here, hence we will have our 2 by 2 matrix. So let's come up with a 2 by 2 matrix here. Let's take the derivative of the first function, cosine of 3x. The derivative of cosine is minus sine 3x. But since we have our angle here expressed as a 3x, by chain rule, we also need to add the derivative or multiply the derivative of the angle, which is 3. Okay, this is also true. Let me move this here. Okay, let me transfer the second function here, because this is also true for our second function. The derivative of sine 3x is cosine 3x times the derivative of our angle, which is 3. Therefore, our given matrix would be expressed in this manner: cosine of 3x, and we have here minus 3 sine of 3x for our first column, and you have here sine of 3x and 3 cosine of 3x for our second column. So with this is now our 3 by 3 matrix, and the Wronskian of the functions, we'll have here the Wronskian of the two functions, cosine 3x and sine of 3x, is the determinant of this given matrix. So going back to the concept of the determinant of a 2 by 2 matrix, we have a formula for that, but looking into the general concept, the determinant will be taken with this, the product of this diagonal, okay, the red one, to be subtracted with the product of this diagonal here. So we simply multiply them. So let's talk about the determinant. So, or again, it's the Wronskian. So this is equal to the product of the red diagonal. You have cosine 3x times 3 cosine 3x. You will have here cosine 3x times 3 cosine 3x. Then you are going to subtract here the product of your second diagonal. We have the negative 3 sine of 3x times sine of 3x. So simply simplify them, and of course take note of the correct processes involved in multiplying trigonometric functions. So you will have 3 cosine 3x, and cosine 3x would be the cosine square or the square of cosine 3x. Then you will have here plus 3. Then you will have the sine square of 3x, or the square of sine 3x, because you have sine and sine here with the same angle. This is only true if we have the same angle. Now, allow me to factor 3. That's why you have here cosine square of 3x plus sine squared of 3x. You can see this identity, which is just equal to 1 as long as we have the same angle here. In short, the Wronskian of the two functions, let me rewrite it here, the Wronskian of cosine 3x, and sine 3x is just equal to 3 times the identity of this, which is 1, or just equal to 3. This is the Wronskian of the given two functions here. And if this is part of a non-homogeneous higher order equation, we will be using this Wronskian and the concept of Wronskian in the process of solving such. Thank you very much for watching.